So we were discussing about the internal defects in the morning. So let's continue with that. Blowholes are nothing but the holes which are inside the product, and that is mainly because of the gases. Then porosity are nothing but small holes, very small holes, which are not advisable because later on porosity can give rise to blowholes when they are in use, when the product is in use. Pinholes is in between porosity and blowholes. Draws or inclusions, that's not a common defect, so you can skip that. So this is what is your blowholes is. So usually these are large spherical shaped gas bubbles. Porosity, there are the large number of small holes and they are uniformly distributed. Pinholes are in between the size of porosity holes and the blowholes. The reason for formation of pinholes is absorption of hydrogen or carbon monoxide gases or moisture content. If the moisture content is more, then also pinholes are formed. This is what is not much common, that is inclusions. These are the non-metallic particles in the metal matrix or the lighter impurities which are appearing on the surface of the casting. This is the surface. This is also surface. This is not internal. This is actually on the surface. This is also called as the dross. Now these are the visible defects. So this occurs because of the insufficient mold strength, insufficient metal, low pouring temperature, and bad design of the casting. Now what are these visible defects? This wash, red tail, swelling, maceron, hole shirt, hot tear, shift. This is the shift, this is the shift, this is shrinkage. These are more common, swell, shrinkage, and shift in sandwich. So every defect has been explained, because many times the question for 5 marks is mention all the defects and explain any 5 defects. So you have to list the defects and then you have to explain any 5 defects with the diagram. So wash is a low projection, this near the gate, which is caused by erosion of the sand. So this is the low projection near the gate, which is caused by the erosion of the sand, and the sand निकल जाता है because of the flowing matter. Swell मतलब सूजन, it is the deformation of mold surface due to the hydrostatic pressure, which is caused by the moisture in the sand. So that's why the sand should be moisture free. There should not be any moisture, because of the moisture there will be not many defects. Misran matlab it is a casting that has solidified before filling the mold cavity. The mold cavity is not completely full and it is solidified. So this much metal is filled, whereas here there is no metal. That is what is called as the misran. And this is because the metal is not flowing properly, or the temperature of the metal is low, or we are pouring slowly, मतलब हम लोग आराम से pour कर रहे हैं, or even sometimes if the sections are thin, then also you get misran. Cold shut मतलब like metal is coming from all the, like you have poured a metal, so metal is coming from, see this is a cavity, so ये जो है rectangle, this is a cavity, and say your gate is here, so metal is flowing from here, metal is flowing from here, and when they come together, this, that is metal which is flowing from here and from here, and when they come together, so they have to fuse properly. So if they don't fuse properly, then you get a gap here. That is what is called as the cold shut. So that's why fluidity is very important. Not only fluidity, even the location of the gate is also important. And the softwares will give you where to locate the gate, what should be the size of the gate, what should be the position of the gate, how many number of gates are required. Like suppose if this is a cavity, this rectangle is a cavity, this is to be filled, and if you keep one gate, then it will take obviously more time to fill. If you provide two gates, one gate here and another gate here, the filling will be faster. If you still feel that I want to reduce the filling time, then you can have four gates, one gate here, second here, third here, and fourth here. As far as possible, it should be symmetric, so that metal which is flowing, they will at the end mate together. See, this feeding is very important. It should be very fast. Like suppose if it is taking a lot of time, Then material which is already injected, which has gone, let's say filling time is say 2 minutes. Then material which is already injected within first 30 seconds will start solidifying. The young injected a material through this gate and the material is flowing inside, okay, and the cycle time is 2 minutes. That means for 2 minutes material is coming inside. So the now material which is here, so that will start solidifying and it will not allow the material to come inside because it is already solidified is out there. So the most important parameter of the feeding system is that material should reach each and every corner at the same time and as fast as possible to avoid the cold shift. This uneven temperature, like molten metal, which you have poured, that is at high temperature, and your mold was at low temperature. So because of this temperature difference, there will be stresses. Like in our home also, moment you enter, you are coming from outside and outside is very hot. So you are not supposed to sit directly in a cold chamber, cold room, AC room. Gradually the temperature of the body has to be reduced. Like suppose my body temperature is 38 degrees Celsius, I am coming from outside, and my room temperature is say 18 degrees Celsius, AC like whatever. So from 35 to 18, you are just going in few seconds. So body cannot adjust. So outside temperature is 35 and inside is 18. So suddenly from 35 to 18, what will happen? Imagine there will be a crack, there will be stresses. So that's why it has to be gradual decrease or increase in the temperature or whatever it is. It has to be gradual. Like I give you 10 assignments at a time, at the end, definitely you will be highly stressed and you will collapse. Instead of that, if I give you assignments, one assignment every week, you can take it easily. You will not be stressed. Shrinkage is because of improper use of the riser. So it is solidification, contraction that occurs due to improper use of the riser. Like here now it is shrink, it is contracted. The material from the riser has not reached properly in the cavity, so it shrinks. So shrinkage will always be there, but then it has to be in all the direction. It should shrink from all the peripheries, not only at one place. This is your hook and drag, they are not aligned properly. So that's why you get this shift. Now this is your core. This is a hole which is not exactly in the center. So this defect is one of the shift, which is more common. Okay, so this is what we have learned. Sand casting, molding, sand gradients. What are the types of the molding sand? What are the properties? What are the different patterns, pattern materials, types of the patterns? What are the pattern allowances? What are the molding tools? And what is the sand molding procedure? Molding machine we have not touched because it's not here in the syllabus. Then what is the use of core? Why the core is required? What is core making? what is chaplet, and so on. Can anybody tell me what is the use of chaplet we just discussed today morning? Anyone?
It is used to hold the core.
Yeah, to give the support. What is the use of chill? Chills. Chill down. Chill down.
To lower the temperature.
Yeah, to increase the solidification, to improve the solidification, so the material solidifies faster. Okay, good. Yeah, Kiran, what is forging?
No idea, sir.
Forging, I had touched the introduction of the manufacturing process that material is heated. वीडियो भी दिखाया था forging का. Material is heated and then it is shaped. आपका जो चीजल है, पंचेस है, they are heated. उसको हम लोग हैमरिंग करके शेप देते हैं. तो उसमें क्या होता है? It is the controlled plastic deformation of metal into predetermined shape. तो इसमें भी आपका डाई रहेगा, उसमें जो शेप रहेगा वो शेप आपको मिल जाएगा प्रोडक्ट के ऊपर बाय अप्लाइंग प्रेशर. मतलब हम लोग क्या करते हैं? हैमर करते हैं. इन सिंपल इंडियन लैंग्वेज, फोर्जिंग मतलब लोहार काम या भट्टी का. तो फर्नेस रहेगा, मटेरियल को गर्म करेंगे, उसको हैमर करेंगे एंड शेप देंगे. सो there will be automatic forging and manual forging. Manual forging is time consuming, but then in manual forging we don't use any die. There is no die. So it is cheaper, but it is very expensive. Like suppose if I want to forge a hexagon and if I am doing it manually मतलब एक राउंड बार लिया, उसको हैमर किया तो एक फ्लैट मिल गया, फिर बाद में उसको घुमाओ, दूसरा फ्लैट, तीसरा फ्लैट, चौथा फ्लैट, पांचवा फ्लैट, six flats you'll forge. So that will take around 10 minutes. But if you are using dice, it will take a minute. But then there will be a die cost. So forgeability matlab it is the ease with which material can be forged. I can forge my students the way I want. I can mold my students the way I want, provided the students are forgeable or students are moldable. Certain students उसके कितने भी पीछे रहो सुधरते नहीं है. That doesn't mean that those students are best. They may be good in some other activities. Just a minute. Yeah, sorry, there was a call from HOD. So forgeability means material should be forgeable and material should be moldable. I said then only you can go for forging. Hello, समझ में आ रहा है चिराग? Are you
Yes,
understanding?
yes,
Yeah,
sir.
okay, good. So why we go for forging when we have casting, when we are molding these techniques? The reason is some components, some material, it can be produced only by forging or it cannot be produced by casting. Like say aluminium and magnesium, they can forge easily than titanium. Hmm? Aluminum cannot, you cannot do sand casting, you can do die casting. Magnesium also you can do die casting. But nowadays, because of the technological advancements, almost no any material can be cast except few material like gray cast iron. You cannot forge it. Why?
That is brittle.
Because it is brittle. Very good. Hmm? And why it is brittle?
Because of the high carbon content.
Good. You are technically good, Peter. As the carbon percentage increases, the brittleness will increase. Will increase. And and in forging we have to hammer it, isn't it? Then pressure is applied. So obviously it is going to break. So the material which has higher carbon percentage, they cannot be forged. Then there is a good refinement, grain refinement in forging. Then its fatigue strength and toughness increases because you are heating it and then it gets cooled. So it's there are some microstructural changes that happens because this is a kind of a heat treatment and the strength and the toughness increases. Then it can give better finish and better size and better tolerances than casting. Like suppose in casting, if you have to keep machining allowance of 2 mm, in forging you can keep machining allowance of 0.5 mm. Nowadays, the forging technology is improved in such a way that you can get the components in plus minus 0.1. So there is no need of machining if your components have tolerances of plus minus 0.1. So this is what grain comparison is shown. If it is a forged component and if it is machine component. Machine component mean it is like this, and in forged components mean it is equally distributed and it goes from center, you know, to the periphery. So the strength is good. What are the different types of forging process? Depending on the temperature, you have cold forging, you have warm forging, you have hot forging, and there is something called the thick forging. So, cold forging, coining is a cold forging, rolling is warm forging, punching, piercing, blanking, these are all warm forging, whereas heading, that is hot forging. You can skip thick soap forging out of syllabus. Then based on the die, it is open die forging, closed die forging, and upset forging. And based on the machine, forging processes can be classified as hammer forging, press forging, and ring forging. Again, you can skip this ring rolling and thixopposing. So either you can have impact load, thump, 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 or you can have gradual load. So based on this type of loading, it can be classified as hammer forging or press forging. So hammer forging means it's a kind of an impact load. And in press forging, you can go gradually, like hydraulic process. If it is a mechanical press, then it will behave like a hammer forging. If it is a hydraulic press, then it will be gradual. Then based on the nature of material flow and constraint on flow, forging is classified as open die forging and impression die forging. Something called as a flashless forging. Flashless forging means if the two halves, if they are not closed properly or if they are not held rigidly, firmly, then small amount of material comes out along the parting surface. That is what is called as the flash, which is again a scrap material which you have to cut. This is called as the open die forging. This is the simplest. The lower portion is called the die, upper portion is called the punch. This अभी देखो ये आदमी इधर है, he will hold with the hammer. See how risky it is. He will hold it with the hammer, ऊपर से पंच करेगा, then उसको रोटेट करेगा. अपने को अभी हेक्सागन करना है, इसको रोटेट करेगा, अगेन ऊपर से पंच, again rotate करेगा. So like that, it is risky also. It is not safe also. Accidents has happened if there is a poor grip or while rotating, and if it slips and this is at high temperature, a person can die. Damage, severe damage also can occur. So open die forging में die is not enclosed in between the flat punch and flat die. In closed die, it's like a injection mold. So you have a proper cavity which will give the shape like hexagon. So you will have 3 flats in the die and 3 flats in the punch. So दोनों के बीच में material रखेंगे and then we'll close the die and we'll get the desired shape and size. So closed dies are expensive. The simple type of open die forging, this is called as the upsetting. And here the work is placed between 2 flat die and its height is decreased by compressive forces. So upsetting is an open die forging in which billet is subjected to lateral flow. Billet is nothing but a raw material. Then these are another forging operations, that is fullering and aging. This is what is called the fullering operation. Like suppose connecting rod करना है आपको engine का. This is your fullering punch. This is a following punch. This is the difference between fullering and aging. Fullering में खड्डा और aging में there will be a protrusion. Like you will get a concave surface in fullering and you will get a convex surface in aging. Fogging is not much common. Basically, it's like open die forging process only. To produce flat surfaces. This is your closed die forging. You have upper die, you have lower die, and this is the parting surface. And you will get this shape. और जो भी एक्स्ट्रा मटेरियल है फोर्ज करने के बाद जो भी एक्स्ट्रा मटेरियल है so you have to accommodate that extra material. So for that there will be cavities this in which that extra material will go, which we call as a flash, and then this has to be cut off. Simple. Because here we are not introducing molten metal, unlike your इंजेक्शन मोड में हम लोग मोल्टन मेटल पोर करते हैं डिजायर्ड एक्यूरेट, सो उसमें फ्लैश ज़्यादा फ्लैश नहीं आता है, लेकिन इसमें विल बी वेरी बिग फ्लैश बिकॉज हम लोग यहाँ पे फिलेट रखते हैं, बिलेट रखते हैं, दैट इज रॉ मटेरियल, और फिर उसको हम लोग दबाते हैं. So the flash can be thick in forging. So this is what is your flash is, excess metal. So the sequence is you have a billet, उसको थोड़ा pre-shape देने का, then rough forging, then finish die, and then you can use one more die, trimming die, to get the accurate shape. Like casting defects, you also get forging defects, like unfilled section, that is section is not filled thoroughly. Coal shuts, that is small cracks at the corners of the forging. This coal shut and casting ka coal shut, that is totally different. Scale pits, it is irregular depurations. Like suppose if you are not clean the die properly for the next forging, and if there is slight inclusions, then that gets adhered. That is what is called as the depurations. And this is mismatch. Internally, if there are ruptures, then that is called the flex. As internal ruptures will occur because of the improper cooling, not gradual cooling, as I told. So the cooling has to be gradual. And grain flow, improper grain flow. So these are some defects. Normally forging defects we don't ask, so you have to concentrate on the casting defects only. Okay, thank you very much thank you Sandra for arranging this extra lecture, because we were slightly lagging and the syllabus is also very vast. So we can back up.
Okay, sir.
Anybody has a doubt? Chirag, Peter.
No, sir.
Okay.
No, sir.
Okay. Thank you.
Thank you, sir. Bye, sir.
Welcome.
Thank
Thank
you,
you, sir.
sir.